and experts from all over the world to talk of robotics and industrial IoT. And also we discussed the challenges. Since last year, we started online distribution both in Japanese and in English to send the messages globally. Now this is the 7th symposium, and today is the day 1. From Germany, the United States, and from Japan, we have invited the leaders of the industrial research, and the theme is Paradigm Shift in Manufacturing Business. Discussed by the global leaders, we have lectures as well as panel discussion. To overcome the global issues such as pandemic and climate change, and to realize the Society 5.0, we need the co-creation on the global scale and the digital transformation. And we are seeing the shift of the paradigm in manufacturing. So what kind of paradigm shift is it? Especially Dr. Johnson and Dr. Kagermann and Dr. Shirasaka participated last year as well. And they will talk about the changes of our society since last year in their lectures. And today from the private sector, from Hitachi Limited, we have Dr. Irie to talk about the practical matters from the front line. The symposium will last for a long time, but I hope that all of you will stay until the end of today's symposium. So I'd like to now introduce the moderator of the panel discussion, Mr. Shuhei Sugie of Future Corporation. Mr. Sugie, please. Good evening, everyone. My name is Shuhei Sugie. I come from Future Corporation. I'm in charge of strategy and consulting, and I am in the division of the manufacturing. I will be the moderator for today's panel discussion. Thank you very much. Before starting the session, I'd like to make one request to all of you. After the presentations, for about an hour, we have a panel discussion. And if you have any questions to the speakers, please go to the YouTube link, and there will be a Q&A site called Slido. And please open the Slido and then enter your question and name and affiliation so that you can ask questions to the speakers.
So we would like to move on to presentations. First off, from the United States, we have Professor Mark Johnson of Clemson University.
Thank you very much, and good afternoon, good evening, and good morning. My name is Mark Johnson. I'm a professor at Clemson University in the United States, where I'm the director of the Center for Advanced Manufacturing, that is a member of the Clean Energy Smart Manufacturing Innovation Institute in the United States that focuses on Industry 4.0 and robotics issues that we are talking about today. So thank you very much. It is an honor and privilege to speak with you today. My slides, I believe, are they going to be going up now? Or do I put those up? Here we go. I will share. Okay. From the beginning slide. Okay, my co-author on this is Dr. Douglas Ramsey from HPT as well. And this morning, I have the pleasure of speaking about 2 lessons and directions from smart manufacturing in the United States based on learning from, especially over the past year, relative to the paradigm shift in Industry 4.0. So one lesson relates to issues of COVID, particularly relative to supply chains. The second lesson has to do with climate change and how those 2 things are closely important issues that are very strong impact on Industry 4.0 issues. Partnerships as we respond to this, and making sure that both Japan and the United States are close partners on these issues, and how that will have positive impact on society. So the first thing I'm going to speak about here is COVID. It has affected every nation. This is our data for the United States from our CDC, our statistics, and lining that data up with manufacturing outcome. What we see is very interesting, that the COVID cases, although they went up, in wave 1, wave 2, and wave 3, really it was during wave 1 where manufacturing, particularly individual firms, learned how to operate and continue producing as individual firms during time of COVID, so that the protocols and methods to operate safely in those environments really have been learned quite broadly across manufacturing. However, there are some notable challenges that have been noted worldwide, related more to not just the manufacturing of individual firms, but at the level of supply chains and understanding supply chains. And really it's highlighted by kind of 4 broad areas that wind up causing this, but the 2 that are most notable are semiconductors and shipping containers. And these are where you have mismatch in supply and demand for logistics. So being able to get the containers to where they are providing as products shift during the time of COVID with rapid change, how that mismatch can affect the ability to get products out. Just as important is semiconductors, where you have products that can be used for multiple applications, like a semiconductor. Once that product is being used in one application, for instance, making mobile phones, there is then a gap in availability for manufacturing of automobiles. So it's very much highlighted the importance of supply chains during time of COVID, particularly where you have long lead time items or critical items that are out there. This is made more important in what is called the bullwhip effect on supply chains, where, for instance, in the classic bullwhip effect, you have changing in consumer demand, results in a disruption and dramatic change in the manufacturing expectation. That is at the top here, the classic bullwhip is information from consumer out to the manufacturer, where all manufacturers want to satisfy that consumer, and essentially it results in a mismatch in supply and demand. The thing we are seeing now is concern and fear over manufacturers being able to deliver results in individual consumers changing their behavior. And as a result of that, becomes much more complex. So the solution to this is actually, or one solution is having key understanding both between manufacturers and consumers, and having information exchange in a way that's in context and can wind up being accessible, so that we wind up having a continual optimization across society of that supply and demand. So that's lesson number 1, is really the importance of supply chain in manufacturing and information technology. Lesson 2 is related to climate change, and of the Sustainable Development Goals. Clearly, issues like the recent UN report, climate change is continuing to increase to a tipping point, a critical point of unsustainability. Certainly, we wish to avoid irreversible damage. I'm very excited that the United States is once again engaging in the COP21 process, working with the Paris agreements, so we can work together. And if you look at where CO2 or greenhouse gases come from, it's really in 3 sectors. You have transportation, vehicles. I think people are quite familiar with the greenhouse gases related to that. You have electricity. So how do we change the GHG related to the electricity emissions? But the one most relevant to what we're talking about today is the industrial sector. And in some ways, it is the most complex of the sectors. Just from this image here on the lower right, you can see the industrial sector is highlighted in this violet colored circle or ellipse. It is a very complex sector in number of subsectors, plus it winds up impacting a wide range of greenhouse gases, not just CO2. So the solutions become much more complex as a result of it. It is sometimes referred to as hard to decarbonize sector. So how do we why it's so hard to decarbonize? Well, first of all, it's not just a matter of getting rid of the greenhouse gases, but the industrial sector is one that provides very good jobs and economic foundation for all of our societies. It provides the goods and also goods enabled services for society. So we cannot just limit having that there because that affects people's standard of living across all of society. However, we need to wind up reducing the CO2. And the challenge is you look at the energy intensity. This is this graph on the right is the on-site energy usage. So that would be the scope 1 energy usage. The vertical axis is the CO2 emissions, both on-site and off-site. So this is scope 1 and scope 2 CO2 emissions. You'll see that a wide range of chemical sectors, forest product sectors, food and beverage sectors, and iron and steel are your largest emitting sectors that are out there. Cement is also often put into that area because on a global level, that these are very, very different processes, though, that are used in each one of these and different approaches to manufacturing. So how do we wind up addressing that together? The challenge we wind up having then is there's 3 big categories you can apply. First is invent new low CO2 processes. The challenge is how do you do that at a lower cost than the process that's used today for your product? The second is circularity. How do you change the feedstocks that are used in the existing processes that we wind up having? And then the third issue is how do we use every bit of energy and carbon most intelligently and most efficiently? And in all 3 cases, this pictures on the right are highlighting the importance of information technology in Industry 4.0 in all 3 of these strategies. The first strategy image at the top is a high performance computing, supercomputing modeling and simulation of a new membrane material that is a biomembrane material that is being developed from the chemistry up through the large scale operation of that material. The development of new materials can be done by computer these days. Second is then tracing where information about the flow of material is. And then the third is, of course, the interconnection of on a site, on a process, and in a supply chain of information. All 3 are essential IoT approaches to addressing climate change. We have some additional structural challenges as we start getting more and more realization that you have both scope 1 emissions, which are by the individual manufacturer, but the scope 2 emissions, the emissions are related to the energy that's used in manufacturing. And then scope 3 emissions are the carbon and emissions that are attributed to the supplies that come into the products that are being made. So supply chain information. Scope 1 and scope 2 emissions, a manufacturer can generally get information to either through their own data systems or through information from their energy supplier. Scope 3 emission becomes much more problematic because this is potentially commercial information that needs to be shared with both positive and negative impacts about the carbon on this. So it is a supplier sharing information to their customer or multiple customers that may be direct competitors. And so where can that information be used? How can that information be used? So it raises the importance of standards, security, attributability, limited use of that data, so that how is that data actually utilized becomes a very, very important issue. So in addressing both these lessons, lesson 1 on supply chains and lesson 2, this increases the importance of smart manufacturing or Industry 4.0 and how we wind up dealing with both the standards, the platforms, the edge of information, and how we wind up sharing that information. It's not just the technical problem we have shared interest in, but also how do we wind up developing the tools that can be used for all firms? How can we then wind up training our people and working together on that? Now, fortunately, the United States and Japan have begun working together on these issues. And I'm very happy to highlight in the last 4 months that the U.S. Clean Energy Partnership has really focused on on renewable energy, power grid, nuclear energy, and decarbonization technologies. I'm highlighting over here the importance of information technology in developing solutions around hydrogen, for instance, which is very important between the United States and Japan. We wind up having a number of meetings coming up, both the G7 meetings, we have the Quad meetings, and as well the upcoming Scotland COP26 meetings. So very optimistic about the future on these, so that then as we move forward, we're not only using that smart manufacturing or Industry 4.0 for our own individual firms, but we're getting economic growth across our entire societies overall. As a result of that, we get better products, our economies grow together, we have more harmonious international supply chains, as well as positive climate in the future. In the United States, the term that's being used for this is how we are building back better as a result of it. So just to highlight on this, I have hopes for the next year as we go through this paradigm shift that we will increase our partnership between the United States and Japan on smart manufacturing and Industry 4.0. Specifically, I am hoping that the Robot Revolution Initiative, MIDI, and organizations like the Clean Energy Smart Manufacturing Institute that I work with develop joint partnerships together. We can align those partnerships not just with Japan, but we can wind up aligning those partnerships with Japan and Germany, where we have shared interests in things like standards, protocols, workforce education, sustainability, and climate. So with that, I wish to thank you for your time this morning or this evening, and enjoy the rest of your conference very much. Thank you very much.
Dr. Johnson, thank you very much. Next, from Germany, we have Dr. Kagermann to make a presentation. So Dr. Kagermann, please.
Yeah, thank you, and good afternoon. And yeah, thanks for inviting me to this session. For me, it's the first time that I have the opportunity to present at this conference. In previous sessions, we had topics like human-machine collaboration and the platform economy. These are all topics which are still on the agenda, but as requested by the organizers, I would like to build on last year's discussion. In Germany, I think like in the US, everybody agrees that we now have to accelerate the digital transformation. And digitalization is at the end understood as the key engine behind all of our technological and societal innovations. So if we go to the beginning of my slides, please, then I have to say that last year there was a lot of concerns, in particular in Germany at the outbreak of the pandemic, whether we were really able to maintain the goals of the very ambitious European Green Deal. But in the meantime, these goals have not only been confirmed, but they were even tightened, in particular for climate protection. That fits to what Mark has just talked about. So that's the reason why I have chosen the title Co-Creating a Digital and Circular Economy, because the key challenges ahead of us are global ones, and we need continued international cooperation. On the next slide, I have summarized, the next slide, please, some findings from last time. The conclusions, can you switch? Thank you. The conclusions are still valid. I just want to highlight in red here what topics have now higher priorities. That's not, I think, a surprise. That's about sustainability and resilience, as we have just heard. And it's also about circular economy concepts. Mark has, let's say, referred to this as well, which bet on taking waste out of today's systems instead of refraining. Resilience was interesting enough on top of our agenda already at the economic crisis 2008, but surprisingly disappeared from the social memory. I think it's a mistake, and it's now back on the priority list, especially in the context of security of supply. Let me now walk you through the 4 steps of the digital transformation. Next slide, please. On the next slide, we have step 1, and step 1 is a digital factory. I have just redlined the key focus areas for the future. It's about time-sensitive networks empowered by 5G. It's building an edge cloud continuum. It's team robotics. It's flexible production cells, implementing industrial artificial intelligence, and still most important, implementing the digital twin, which is a virtual representation of the reality, which is implemented by the asset administration shell. We believe that zero defect production is within reach, and progress there would support the implementation of new results or value-based business models. For example, a guaranteed quality level or a guaranteed workload level. Step 2, on the next slide, please, is the value creation architecture of the business model. You see on the left-hand side the smart services stack. That has been successfully implemented in the meantime by many companies. And you can also see the importance of artificial intelligence of all 4 of the layers, from data curation, it's a lower end, via machine learning, until to user modeling at the top. Data is now viewed as an independent resource, and the flow of data can be decoupled from the flow of goods and services, as illustrated on the right-hand side. And here you see that, for example, a trusted independent specialist can collect raw data from all the members of a business network, refine those raw data into smart data, and then provide database services on demand to all the members of the network. In spring this year, we have celebrated the 10th anniversary of Industrie 4.0, and in hindsight, we can say that the promised benefits were verified, and we have achieved a very broad acceptance in Germany to implement those concepts. However, they are still not rolled out at a large scale. Most of Germany's small and medium-sized enterprises are on stage 3 of the acatech maturity index, which is defined as seeing what is happening. Only 5 to 10% have reached stage 5, which is defined as anticipating what will happen. So on the next slide, please, we see that SME enablement is an ongoing challenge, I guess not only in Germany, but in most countries, at least I speak to. And we try to address it by a lab network initiative. LNI stands for Labs Network Initiative, and that provides test beds tailor-made to the requirements of SMEs and open for international cooperation. So one example on the left side is testing and validation of the asset administration shell that is done in cooperation with Japan and the US. But you see that there are also many other topics we are covering together with also other countries, for example, time-sensitive networks or edge management. So that's why we view these vehicle LNI as a promising vehicle to bring international cooperation into praxis. Another challenge in building a digital enterprise is business networking. Next slide, please. The business models of the digital age are based on smart services. And we all know that smart services are bundles of products, physical and digital services, and they aim to solve a customer's problem based on the insights in his preferences and needs. So at the end, no company can do it alone, and building a business network will be a key competence for digital enterprises, and that in 3 ways. The first is that they need technical networking ability, which would include an API-based IT architecture or applying semantic interoperability. That's not an easy game. The other one is business networking ability, which includes to build an orchestration model and a community portal. And last but not least, it's about legal networking ability, which includes a value sharing model, certification of partners, or a code of conduct. Next slide, please. So the final step towards a digital economy requires growing up ecosystems, and that comprises all societal stakeholders and needs to some extent the strong involvement of governments. So it's about resilience, it's about self-determination, sometimes also about achieving digital sovereignty in a connected economy. The European approach is Gaia X. It's an initiative we have discussed already last year, and as I know, it will be treated in more detail in subsequent sessions. So companies, in particular small and medium-sized ones, as you know, are concerned about protecting their intellectual property and about getting a fair share of the value generated through data sharing. The challenge is to establish a trustworthy data supply chain and data sovereignty for members of an open data ecosystem, and that was addressed some years ago by the International Data Space and recently by this Gaia X initiative. That is nothing else than a framework for collaboration in a connected economy. It's based on shared architectural principles and values like transparency, interoperability, frictionless portability of data and applications, and also to avoid lock-in by giving customers a choice to determine where the data are located, under which level of security or under which legal regime. Therefore, an easy onboarding of new business partners into an existing open data ecosystem and a trustworthy exchange of data can in principle be supported by central digital business-to-business platforms. That was an approach of the past. But Gaia X has adopted a different one, a decentral and more federated approach, which allows direct peer-to-peer exchange of data between ecosystem partners. The organization provides the technological, the legal, and the business guidelines, the standards, and the enabling digital services. It's now supported by more than 2,000 partnering companies all over Europe, and more than 100 use cases show the potential of data sharing, in particular cross-domain data sharing. The automotive network Catena X, which is here on the top of the slide, that is an example of an ecosystem that tries to create a data-driven value chain on Gaia X, built on Gaia X, and they extend the focus from intra-company exchange of data to inter-company exchange of data. Next slide, please. In the next slide, we see that in a connected digital economy, this data-based value generation depends on the creation of data spaces. And that's why the organization Plattform Industrie 4.0 has now decided to drive the formation of a data space Industry 4.0. So the idea behind is to establish a collaborative network of technical, legal, and business information for tomorrow's digital ecosystems. And that should be also a common basis for companies, which these companies can use for multilateral data exchange and cooperation, in particular addressing small and medium-sized enterprises, of course. The first industrial use cases are condition monitoring, it's manufacturing as a service, and supply chain traceability, and there is a position paper which is available in English on the website. I would like now to switch to resilience and security of supply chain, something Mark has mentioned as well. Next slide, please. Next slide, yeah. Building supply chain resilience can take different forms, as you know. That includes transparency, more transparency, creating an adaptable production and logistic processes, building redundancy in supplier and transportation networks, or the ability to switch seamlessly between members of these business networks. So these are all capabilities we have mentioned earlier when we discussed the 3 ways of networking ability enabled by digitalization. Acatech has published several reports on resilience with a specific focus on the healthcare and the automotive sector. This slide highlights some of our recommendations for the automotive sector. In a nutshell, it's accelerating the rollout of Industry 4.0, in particular, including Catena X. It's strengthening the microelectronics value chain. Mark has mentioned semiconductor. It's more or less the same. It's underneath the microelectronics. And we try to launch in Europe, let's say, a next important project of common European interest. The first one, by the way, was launched already 2015, when many German companies felt that we have a weakness in Europe, in particular if it comes to semiconductor. Now, the third one is, yes, implement circular economy concepts, in particular for traction batteries, and last but not least, a rapid implementation of European data spaces. Next slide, please. We have an initiative in Germany which is called the Circular Economy Initiative, and they have published their final recommendations. These recommendations are shown on the next slide. Next slide, please. So they emphasize the need to think beyond just recycling and promote new product designs that strengthens the ability for repair, reuse, and remanufacturing of parts and components. We have seen it on one of the previous slides. And that increases, obviously, the circularity of resources, but also opens opportunities for new so-called circular business models. And if you combine this strategic direction of circularity with the strategic direction of Industry 4.0 and smart service, where we want to shift the value proposition of the business models from product to results or to value, then you see that you can span as kind of a matrix of strategic options to achieve both the transformation to a digital and a circular enterprise. In my next slide, please, I want to build on last year's discussion of new ways of working. Next slide. The increasing penetration of workplaces with tools and methods of artificial intelligence leads to the rethinking of processes and tasks to be more adaptable to the behavior, preferences, and needs of workers. Next slide, please. So we can do this in taking advantage of collaborative teams of humans and machines. And the pandemic and the related need for social distancing has led to a rethinking of what task should be performed on site or which one can be done remotely as well. And we have discussed this in the last months with a group of, I would say, roughly 15 German executives from various industries, and published then our finding under this title, From a Culture of Presence to a Culture of Trust. And there are 7 core theses, and they are below this picture here. And I just want, let's say, to mention 3 of them as example. The most important for me is increase the empowerment of employees through openness and trust. We have to rethink the new role of the office. How does the office of the future look like? And co-design the corporate culture. So in my final slide, which is the next one, the next and final slide, I have summarized the 4 steps towards a digital economy, digital twins, digital factories with industrial AI and team robotics, digital business models based on smart services and dynamic business networks, as well as global data spaces, which are enabled by decentralized federated data exchanges. These are, to my feeling, key components of a connected digital economy. I think we have made some progress on the first 2 steps, and I believe we must now extend our focus more on steps 3 and 4. Digital transformation is a key enabler of a resilient, more circular and sustainable economy, and therefore I think continuous international cooperation and also conferences like the one we are just having here together are really needed to shape innovation together and to master these upcoming global challenges. Thank you.
Thank you very much, Professor Kagermann. Now from Japan, we have Professor Shirasaka from Keio University to present. The floor is yours, Professor. Thank you for the introduction. I am Shirasaka from Keio University. I was invited to participate last year. I talked about system development methodology, which is my specialty. Today, I'd like to give you the recent progress we have made in this area. Let me share the slides. So what I like to talk about is Society 5.0. This will be explained further, and I want to focus on architectural design using digital technology. How can we design transformation? I introduced myself briefly. So system development methodology is my specialty, especially systems architecture. So let me talk about this system architecture. I'll give you the definition of ISO. What it means is really this. We have objectives. Using means, we want to realize these objectives. So how can we connect them together? How can we use means to achieve objectives? These mechanisms between objectives and means are expressed by the word architecture. So we have objectives. Using the mechanism architecture, we can transform means into values. But more recently, what is happening is that we have new means, that is the digital, which is significant. Using these new means, we can, of course, achieve the conventional objectives, but we are not limited to the conventional objectives. Since we have new means, think of cooking. We have new ingredients. We can come up with completely different menu. So we have completely new means, the digital, and use the architecture to create unprecedented values. Completely different set of values can be created thanks to the digital. I actually talked about this holistic view last year. I focused on this, so let me once again stress this holistic view. When you try to see holistically, we have to think of three axes. One is time axis. So there is a start and there is the end of the time. Secondly, spatial axis. You have some object and its surrounding. That is a space. And last axis is semantic axis. It's hard to understand, but you would be asking why, what do we have to do, how can you do? So asking questions like why, what, and how can be represented by semantic axis. I will give you some specific example. Think of Uber Eats. So when you place orders for a delivery, you make a telephone call. But now, orders can be placed on internet instead of telephones. It's same placing orders, but how hard means is different. Now, when you have a platform that encompasses multiple stores, someone wants to make orders place orders to different stores, you can simply go to one place. So this is what? The platform. Uber Eats is actually one layer up. If you ask what's been changed, you can simply arrange delivery persons digitally, meaning delivery can access to areas which were not reached by conventional delivery services. Or you can place orders to the stores that you were not able to. So the value has already been changed in the eyes of users. So utilizing the digital technologies, we can actually change the value provision. So it is important to think of this issue as additional access of semantic. So let's now talk about Japan's approach, specifically the project that I am involved with. For one thing, as I said last year, we have set forth the Vision Society 5.0, that is to connect cyber space and physical space. We would like to highly integrate them so that we can achieve human-centered society. I will give you more specific explanation of Society 5.0. We have cyberspace and physical space. What is different in Society 5.0? Today in Society 4.0, something is processed in cyberspace, and the human beings will be there as an intermediary to provide that to physical or physical information given to the cyberspace. But in Society 5.0, there are sensors installed. Information will be exchanged automatically. Robots and drones can be used and operated. So without human intervention, this whole cycle will continue to run. In the cyberspace, we have AI or deep learning. So there is learning taking place in the cyberspace without human intervention. So this is the cyber-physical vertical connection. Now with this vertical connection established, well, cyber has already been connected to internet. So we will have further horizontal connection, meaning that physical can be connected further. For example, you make a reservation at the hospital. Based on the reservation time, there may be the automatic driven car coming to you, pick you up. The information about congestion will be given to the hospital so that by the time you arrive at the hospital, you don't have to wait, because the hospital can make some arrangement. So this is just one picture, one example of New Society 5.0. Think of human journey, your life. There are different points that you go through, but they are all connected. You go through different points. All of these points of systems were not coupled, but now we can connect them together. In other words, you can optimize a series of user experiences thanks to CPS-based human-centric society, Society 5.0. In order to realize this type of society, what are needed? There are three major things that we need. In order to create a society like that, we have to design it. So we need people who design it. But to do this, we have to have methodology, because what wasn't connected is going to be connected. Also, the mobility and hospital, for example, will be connected. Completely different industry sectors will be connected. So you need an actor who can actually connect them together. You have to design cross-industry collaboration. So actors are needed. So human resources, methodology, actor, three factors are needed. With that in mind, as I said last year, we established Digital Architecture Design Center established in May 2020 to achieve cross-industry action. We want to be an actor that is needed. So by being engaged in designing activities, we want to educate human resources and establish methodologies. Yes, we are the actor, but by taking actions, we also want to develop human resources and establish methodologies as well at DADC. So what type of architecture do we want to make? Cross-industry architecture that can establish consensus among multiple stakeholders. We can go beyond cyber and physical difference, make sure they are aligned together. So we want to create a holistic blueprint. So the architecture that DADC want to establish, well, I'm sure architecture is well known to IT people, but the architecture that we want to make is not simply hardware and software. It includes rules and regulations. The things that are related to governance are also included in DADC architecture. In other words, we have to create new rules and regulations. We have to change currently available rules and regulations. So once again, in those areas, we want to be an actor. So at DADC, the various stakeholders gather together so that they can discuss at neutral place. So that is the role that DADC wishes to play. There will be government involved, and surely there will be private sector involved. They can all propose agenda that we can discuss. Also from academia as well, or other experts, even from outside Japan. The people should be involved, representing different sectors, because this is a neutral place where we can get together and design a new world. This is something that I never discussed last year, but we are currently doing in both three major projects. First of all, vertical connection. So it's the designing connection between cyber and physical spaces. I said there are three projects. The first one is vertical project. The second one is horizontal coordination project. Design in both directions. We want to make sure that people are safe. We need to protect people. So governance is also as much needed as the other two. So these are three perspectives that we need: vertical, horizontal, and governance. From these perspectives, we are running our projects. For everything, we have to have three perspectives, but you have to be able to start small. So we have separate projects, although we know that we need all of those three perspectives at the same time. So the governance, to start with, we have smart safety project. In a new society where AI is more evolved and advanced, where everything is connected, safety must be assured in the design. If something happened, the person should not be responsible, because we will involve AI, many more things will be connected. There will be unthought of issue which may arise. So we want to think about the needed governance in smart society, that's smart safety. And secondly, how we are going to connect cyber and physical in order for both spaces to be merged strongly. we want to design mobile robots, especially drones. Thirdly, this is consumer-driven mobility as a service. Where in Japan, population is declining, especially in rural community. Mobility as a service is much needed when the population is aged. So what sort of system is needed in an aging community? So these are three major projects that we are running. Again, these represent three different perspectives: vertical, horizontal, and governance. As we design our architecture, we issued an interim report, although that is only available in Japanese. Let me summarize my presentation. So we now have new means, digital technology, and therefore we are able to provide new values. In order to realize those new values, Japanese government set forth the vision of Society 5.0, which is human-centered CPS society. To enable this, we have to design architecture. What do we need for designing architecture? We need people, methodology, and actors who actually take actions. As an actor, we established DADC. So vertical, horizontal, governance are three major projects that DADC is running so that we can design human resource development, methodology, and actions. With that, I'd like to conclude my presentation. We are preparing for a new society, especially cross-industry society that we want to build. Thank you very much.
Excuse me, there was a technical problem. Next. Okay, so we have Dr. Naohiko Irie to talk about the Omika works of Hitachi. Please. I hope you can hear me. Okay. So I am Irie from Hitachi Limited. So I am in the Omika Works, a control system platform division. I work as a senior strategist for the future platform and other strategies as a whole. And thank you very much for inviting me to make a presentation here. It's an honor for me to do so. So let's start sharing my slides. So this time, I'd like to talk about past efforts and future of Hitachi Omika Works, which was recognized as an advanced factory lighthouse by World Economic Forum. First, let me start with the overview of Omika Works. Omika Works was established about 50 years ago in Ibaraki Prefecture, and this is we wanted to become the world leading factory for total system. We have about 4,000 employees of Hitachi as well as affiliated companies. So what we provide products are in the social infrastructure, especially in energy and mobility or train and industry, mainly steel and water. So in any case, those are the industries which require the stable supply, for example, supply of energy and the stable operation of the trains, and also the stable operation of the factories and stable supply of the water. So we are providing those products and services, and we provide the control systems for them. So on this slide, we are explaining the examples of our products and services. At the bottom, we have plants, the frontline facilities, and we use our control panels to control them. So control panels, the hardware and the software, also the control system as a whole, the monitoring system or planning system, all of those systems are what we provide. Last year in 2020, in January, this was announced. The World Economic Forum is famous for Davos meeting, and first time in Japan, we were chosen as a lighthouse factory in Japan. So it was a big honor for us. So 44 factories at that time were recognized as a lighthouse factory, and about 10 factories increase happens every time, and as of 2020, this was the first lighthouse factory in Japan. So at the time of the being recognized as a lighthouse factory, those were the evaluated points, 5 points. First, our plant, high efficient production model, and with that, the lead time of the production can be reduced by 50%. Dr. Kagermann talked about the digital factory. And in addition to the hardware, we also provide software. So efficiently and stably to build the system, we introduced the autonomous decentralized framework. That was the second point. Number 3, basically no defects, and we provide a whole system. So in order to realize that, we introduced a comprehensive system simulation environment on site, so we can have a high quality system design. Number 4, after delivering our system, there will be a system operation and maintenance support that we provide. More recently, there are a lot of concern about the cyber attacks. So defending the cyber defense, we have a cyber defense drill testing facilities on site, so we can provide security support to our customers. Number 5, in operating our plants, when the power stops, whole factory operation stops. So from the perspective of BCP, we have a PV and other batteries and control energy management system was introduced so that we can enhance the BCP using FEMS. So today, I will talk about the highly efficient production model. Next slide. So this is the accomplishment. So about 20 years ago, we have started this process of reform. So this is a background and what we have been doing, especially design and production processes reform and digital computerization of manufacturing sites, and also the dynamic response to the production changes. Now, the efforts at Omika Works led to the various concepts. And for the IEC factory for the future, mentioned our concepts. So we try to send a message to outside of the company, and we are also working on the standardization. So what we did, the first step, 20 years ago, what was the situation? The production processes, preparations, and also the organization on the shop floor, there were a lot of confusions. Because of that, the flow of people and the goods were something that we started to organize. Especially the production process and design process as a whole. How do you reform it? That was the first step. So before the reform, there were about 600 steps. That's design, production steps. And introducing modular design and others, we spent 2 years to reduce the number of the steps to about 100 steps. And based on that, we moved on to the next digitization. At that time, the front line looked like this. It was very analog way of doing things. For each step, there were Kanban, and we tried to look at the Kanban to understand the progress. Or there was a cup andon shown on the right. So the status of each station was notified to those people who are near those stations. And we want to digitize this. So that was the first step. Next slide. At that time, the devices, IoT devices, were not easily available. So we started to utilize RFID. 80,000 RFID cards were introduced for products as well as for people, so that we can look at the work progress, status, and worker information. And those information can be digitized. By using RFID, where products are and who are in charge can be understood. And based on that information, the instruction can be given digitally. So this is the digital Kanban and work instruction and work progress. When manufacturing things, we go through various steps and the current status of the process and who is doing what and where the products are. You can see this even when you are far away from this process. So with this, on the front line, with their different ideas, they can also start the various reforms. And when the management people look at this, they can also optimize and improve the efficiency from the top level. So this is how we worked on the reform of the manufacturing. And higher level of this is shown here. This is a factory simulator. So what we manufacture, in fact, is quite various. The control panel, for example, the wiring could be different from one product to another. In delivery, sometimes it's very tight, and for other products, it's not so tight. So different requirements. So how do you level the requirements? And how do you optimize it to the production schedule? This was done manually in the past, but using RFID, the status at the front line and production plan, and also the skill level of workers, and review of the processes. Using the data from RFID can be done more flexibly, and you can do the simulation, so you can optimize the schedules. So we created this factory simulator and started, we are using this on the actual shop floor. So this is a current situation. We have 2 lines. And for the assembly line, RFID is used, and also the video is used to visualize the workers and visualize the operation. And by doing so, we navigate the assembly and do the simulation of the factory, and to support the improved awareness so that we can improve the efficiency. Another, this is a total automated line, PCB production, actually, especially mounter, it's fully automated. So for this, we get the information from each equipment and try to visualize, and also inventory management and the maintenance of the equipment and so forth. This is not only for the manufacturing, but including the inventory of the components. In the past 20 years, this is what we have been doing, and the reform of the front line, it cannot be done overnight, so this is really step by step. Technologies evolve, and together with them, the better methods need to be utilized. And also, next slide, in order to promote this, the front line and the management need to work together. They need to collaborate. So shop floor people, there could be some resistance or not acceptable. At the beginning, we had many cases like this. So we need to solve those issues one by one. And this needs to be done based on the mutual understanding between the two. Next. I'll talk about the future efforts at Omika Works. Dr. Johnson, Dr. Kagermann also mentioned this, but for the factory operation, those are the global uncertainties, and they have a lot of impact. Rapid shift to carbon-free society, disaster pandemic, global supply chain divisions, and meteoric progress of digitization. And those can be opportunities, but also challenges. So this is our challenges in terms of our KPI, for example, CO2 emission. Ideally, we would like to achieve 0 by 2030. Due to the COVID-19, the workplace occupancy of the employees is now down to or lower than 30% to prevent the infection. Also, the supply chain disruption. This is not only due to the COVID-19, but also due to the disasters. The lead time of the electronic components procurement is now 2 times longer. So one of the challenges is how to not to inconvenience our customers. And we have now a lot of open source software, and we are seeing more and more of them used. So for example, 3 times increase or 5 times increase of OSS. So how do we utilize it? And how do we eliminate the security risk? Next. So in order to resolve all these, the ordinary capability is what we have on site, and linking the ecosystem, many changes that we understand, and we want to also seize these to transform our behavior. So we want to acquire dynamic capability shown on the right. So it's not just Omika Works, but our suppliers, customers, and remote employees. We need to link them with data so that the environment and also the training, procurement, and value provision to the customers, we want to realize all of them in a sustainable manner. In order to do this, what we have been doing until now, that is the use of the data in our plant. We want to expand this to the value chain of the upstream and the downstream. And we want to link it with data so we can improve the quality as well as grasp the client-side incidents so that we can quickly deal with those changes. Data platform and organizational efforts are being made. Thank you very much. That concludes my presentation.
Thank you, Mr. Irie. So for about 1 hour or so, we would like to have this panel discussion. During this panel discussion, as Professor Shirasaka, who made the presentation, this was a recording. He was not able to make it today, so we have 3 panelists. Professor Johnson, Professor Kagermann, and Mr. Ii. I will serve as a moderator in this panel discussion. So, this is the overall panel discussion scenario. We have 4 major themes to discuss. The first theme, Professor Johnson, Professor Kagermann, and Mr. Shirasaka. I'd like to ask you to look back on the past year, what has been the change in the past 1 year. So that will be the very first topic. I would appreciate your comment. And the second theme, after this past year change, we want to look at the underlying trend, the underlying consistent concept. There may be some differences between US, Germany, and Japan. So I'd like to look at the underlying consistent concept. And thirdly, I want to discuss possible solutions to overcome some of the challenges that we face. Where do we have to collaborate? And if time allows, I'd like to take some questions from the viewers. And lastly, I'd like to invite Professor Johnson and Professor Kagermann to share with us what you expect of Japan and of RRI before we close this panel discussion. So for your information, I'd like to share the slide. This is the recap of what we discussed last year, the last symposium. We talked about how we can disseminate new frameworks for industries. We discussed how academia should be involved on a long-term basis. And the second point that we discussed is the collaboration. Not just individually, companies and countries need to collaborate. And we talked about the importance of collaboration. And thirdly, we talked about paradigm shift. We have to have the bird's eye view. We have to have systems approach. So these are the topics that we discussed. So we would like to start the discussion on the first topic. But before that, I have received comments from Professor Shirakawa about the first topic, his view on the changes that took place for the last year. Let me read his message out. In Japan, in this past year, there has been even stronger focus on anything that is digital. For example, the launch of the digital agency in Japan and the design of
Oh, did we lose him? I think you're back now.
I'm sorry about that. So METI set forth the design of governance innovation that also had a significant impact. So there has been a lot of emphasis on the digital, but at the same time, Society 5.0 or CPS, when you think about these visions, the digitalization alone cannot achieve objectives. So that's what he said. So there may have been excessive emphasis on the digitalization, not enough discussion on how that should be related to the physical space. For human resource development, once again, perhaps attention is placed on engineers and data scientists, but we have to emphasize the shortage of architects who can design the architecture. DADC and digital agency are both having difficulty in finding appropriate skills. So that's where we have to change. So when you talk about change, we are very good at changing on a single loop, like running PDCA. But at the same time, we're not in Japan good at running multiple loops. And then we have to think about changing the society. It's not just human resources, organization and society, triple loops. And that's the area where Japan is quite weak. So Professor Shirasaka is trying to improve, but he would be interested in how Germany and the United States are trying to change multiple areas. How can they run this triple loops? So that's the message that I received from Professor Shirasaka. So with that in mind, we'd like to proceed with the panel discussion. So Professor Shirasaka talked about the emphasis on digitalization. So I'd like to ask the same question to Professor Johnson, Professor Kagermann, and Professor Irie-san. Starting with Professor Johnson, first question, what has happened in the past year?
So it has, comparing to last year, one of the topics we all talked about was the exponential growth that was going on around digitalization. I am happy to report that yet one more year, exponential growth continues, and it will likely continue the next years ahead of us. So that will not change at all. It is a change of constant change, I guess, is the way to think about it. I think just as meaningful then is that as a result of that, that is increasing data, is increasing the importance of who has the data, when you get the data, why you get the data, and how you manage that data. I think this actually increases the importance not of bottom-up approach, which is the computer scientists and the information scientists coming from the bottom up, but literally from the top down. And I think every one of our presentations talked about governance at some level and how we wind up governing that data. And that is going to become increasingly important as we move forward. I would also say one major change that has happened in the last year, it's not a major change, it is a change that we can all report, is that all three of our governments as our society have held various transformations of our new elected leaders. By the way, congratulations to Japan this last week with a transformation there as well, in Germany and the United States. And we are all meeting together still. So that is, let's start out with, that is also the other good thing that is happening. So what I would expect is that we continue this exponential growth in the data. And by having good governance around it, all the way from our government level down to our data governance level, that winds up becoming something we can continue to work on together. I think an important issue around governance, it's important to have rules, it's important to have regulations around governance. And I think in the United States, whether data around information for manufacturing information or personal information, this has become very front page news about who handles your data, why they handle their data, and how they get that data. One can think of, Facebook as an example. I believe it was on the news yesterday. How they're dealing with data, and this gets to an issue not of rules and regulations, of something called norms, which is to say, what is the societal accepted practice? And norms evolve over time. That's the difference between rules and regulations and norms. And I think we need to figure out around our data, how do we build structures so society norms can be integrated into that data more effectively? And that process moves faster. That has to get to how we design the governance structures. In the semantic structure that was presented earlier, you had the why and how and what question. The who question really matters on that semantics. And I think that's an area that we continue to wind up having an important area to understand. And we are all evolving forward together on that.
Yeah, might be I continue?
Please, yes.
Yeah, in Germany.
Yeah,
I would say in Germany, now not a surprise, but number one is the weakness in digitalization, in the day-to-day digitalization. So we made a lot of progress in very sophisticated areas like Industry 4.0, but on the other side, when the pandemic really hit us, you see weakness, first of all, in the administration. I think the digital expertise in our administration is not the best ones, followed by education, which from my point of view is to some extent a disaster because the regulation was too strict. Let's say teachers wanted to reach out to the children with their own devices, but then regulation was forbidding it for data security reasons. That's the second point. And the third point was in the healthcare sector, we did quite well. But if you interview, and I did this with a lot of people because we did this report on healthcare resilience, and then you touch on digitalization. And I can tell you, I think most of the key people running the biggest hospitals in Germany were upset about the level of digitalization, which is something I think we know for 20 years. So I'm upset as well. Because I think when we developed the first hospital system in SAP at the end of the 80s, I think it's 30 years ago, it was about bringing digitalization to the administrative processes, which saves time of the doctors for the patients. Instead of that, the doctors and the nurses have more to take time, let's say, to fill in documents and forms instead of taking care. I think that I have to say that is something we have to overcome. The second point was there was some confusion on Industry 5.0 coming from the European Commission. There was a paper which I felt was not really addressing the original intent of Industry 4.0. So the platform has explicitly said we continue with Industry 4.0 because resilient was addressed from the very beginning, because these transparencies, these dynamic ecosystems was in the first report. And that is a base for resilience. The same is for sustainability. I think one of the key topics we made at the very beginning was we save energy and we save materials because we shift a lot of stuff to the virtual space, and therefore I think you dematerialize. So therefore, as we reconfirmed the goals of Industry 4.0 with, let's say, focusing indeed more on sustainability, and Mark mentioned it, therefore data flow is important. And also this ecosystem building, it's also for sustainability, because you mentioned the flow of CO2 and where can we reduce CO2. And that, I think, is one of the pieces behind the idea to focus on intercompany data exchange because of it. And by the way, resilience as well. That you want to know where the stock are and where supply chains can break. So that was the second one. The third one comes to that, and that is this ecosystem point. I think we talked about Gaia X, etc. I will not go into that, but I think that continues and has some traction. My fourth point is society. How to say it? I will make an example, because that's something I'm really involved since many years, and it's one of the topics Mark mentioned, that is transportation sector. He has mentioned the industry, which I think works pretty well in Germany. Decarbonizing the industry is tough, but because we did this shift in the energy system in 2013, I think we have already spent billions of money, and therefore I think that is not the biggest issue. In our case, it's more the housing and the transportation sector, honestly. And in the transportation sector, it's because Germany is a country for manufacturing cars. So it's not only about, like in other countries, shifting behavior of people, but it also goes to the fundamentals of our industry. And here I have to say that a key point is how can we upskill people, because we will lose a lot of jobs because of automation and because, let's say, electric vehicles are just simpler. But on the other side, we need jobs in other competencies and capabilities. And the question is, are we fast enough? And how good are we in reskilling the workforce? How fast and how much can it be done? That is one of the urgent questions we have, and in particular, again, for the SMEs. So we have built some so-called transformation centers where the large companies open up their, I would say, capabilities to do strategic personal planning. They have their own online universities, and they open up these capabilities to SMEs. So that in a nutshell is where we are. There is more, but I think that I want to address at the beginning. Yeah.
川間先生、ありがとうございます。かなり。
Thank you very much, Dr. Kagermann. I think you had talked about the next topic and then the next topic. So, Dr. Irie, your progress, your evaluation, also Dr. Kagermann also mentioned some topics for the future. So, Omika Works and the Hitachi Limited at your place in the past year. Any major challenges or anything that you have focused upon? If you can go deeper into this, are you trying to overcome those challenges? Could you comment on those points? Okay. First, in the past year, in operating a plant, the biggest factor was the impact from COVID-19. And to prevent the infection, how do you operate the plant? And also, of course, we should not sacrifice our productivity. So maintaining the productivity and at the same time, how do you deal with the pandemic? It was one of the major challenges. And also COVID-19, and other than that, the procurement and decarbonization, there are different KPIs that appeared for a plant, and we are more aware of them. That probably is the major change that we experienced in the past year, especially in the first half. To prevent the infection in the plant, we worked on how we change the work style in the plant by introducing IT. Dr. Kagermann talked about education. IT literacy education was necessary, and for the future shift of the personnel, we have to make sure that the people have multiple skills. That has become a major issue. And for that, how do you deal with that as an overall organization? This is a challenge, and this is something that we have to work on. Another thing, we talked about the supply chain, decarbonization. In changing our way of thinking, we should not be close to our own factory. For the survival of the plant, we have to also look outside of the plant. So in the ecosystem, we live in our ecosystem. So how, as I mentioned in my presentation, how do you incorporate those changes so that you can change your own behavior? Especially, it's not just the IT. Organizational operation is another thing that we have to do. So we are still in trials and error process. So how do you change the siloed organization so that we can be more agile? And we have to do this as we work to introduce more IT technologies. Thank you very much. Let us move on to the next topic and continue the discussion. And looking back at 1 year as a background, there have been changes of the concept, and Dr. Johnson talked about the use of data, and Dr. Kagermann talked about the Industry 5.0 and so forth. So those are the major changing, and what we have achieved and what we failed to achieve. So based on that, medium-term and long-term efforts, both in the United States and Germany, could you make some additional comment on that? Let me start once again with Dr. Johnson.
Professor, you're muted.
Sorry, I had muted myself. Thank you. Yes, building on the conversation, particularly about workforce that Henning Kagermann, Dr. Kagermann had spoken about. This is part of a broader issue of looking at fairness, even between firms. As we move forward on Industry 4.0, one of the concerns we have is saying, how do we make sure not just our leading firms have these capabilities, but all firms have these capabilities? And that becomes, there's a wide disparity between not just the know-how, but the ability to invest, the ability to operate, the ability to take advantage of new technologies. And why that's important is all of these firms are in supply chains for something, right? For somewhere in our economy. And if we, a supply chain is a chain, and it is only as strong as the weakest link in that chain. And often it's not a lot of visibility to where that weak link is. So we really need to focus not just in how do we demonstrate our own capacity to use this, but how do we get that out further into our entire community of companies. From that, they need a much stronger connection to, we look at this as workforce and training. I don't think in my career I have ever heard people say, we have enough workers and they have enough training. This is a capitalist society in the United States. To some extent, we will get the workforce depending on the economic signals people have for paying workers that have this skill set to be able to accomplish their goals. So if you have a more capable worker, they will inherently be demanding a premium or able to get a premium price. Having said that, then we need to make sure all of the workforce has at least the opportunity to gain that. So a real focus on, for instance, training in our 2-year colleges, making greater access to this so that people can afford this, particularly across all social groups. For instance, in the United States, for getting training at community colleges, a real focus. I know this does not sound like it's Industry 4.0 in computers, but information technology, but having childcare for women who are working in the manufacturing sector to be able to upskill and take the time to do that, as well as having families. Very important issues. These are all connected together. How do we as society take these on? And what we call this in our area of South Carolina in the United States is actually our new industrial commons, is what we're calling this. So how do we have those issues that all the firms in our region will wind up benefiting from it in terms of manufacturing firms? There is a blending between manufacturing and service firms, manufacturing information firms, all of whom are needing that high-skilled worker. I think this is an area where, in particular, we can work together with Germany and Japan, because we all need to train our workers on this. So how do we wind up, how do we share information about curriculum and content? So the open education movement should go hand in hand with the open industry 4.0 movement. And then we wind up taking responsibility and really impacting people. Again, back to the Japanese model of society 5.0. How are we helping people in doing this? It is more than just helping the companies with a given process. It is actually getting that knowledge out to society. And it's going to get more and more important to do that as we move forward.
Thank you so much. Professor Kagermann, you talked about reskilling, the human resource development. So responding to what Professor Johnson said, could you also share with us how EU is trying to solve this problem of human education?
Thank you. I will take again this example of the automotive industry because it's our largest one. We have a national platform like that for Industry 4.0 for mobility, and I'm sharing this since 3 years. And one of our work groups is headed by the head of the unions, which is important. So it's not only the unions, it's everybody, and it's big companies, etc., but it's headed by the head of the unions. And they have adopted, from my point of view, a very forward-looking approach, which I like, and I think we could transfer to other sectors as well. I think what is the challenge? We have existing supply chains like that for combustion engines, which we have to ramp down, but in a manner that's not breaking, because there's millions of people. So you have to do it in a controlled way. On the other side, we have new ones which we have to ramp up. The electric engines, the battery, the power electronics, etc., fuel cell, etc. So what you have to do is you have to see that you ramp one fast enough up and the others ramp it down. And to do so, I think we have looked in detail to the value chain and identified areas where we are competitive and areas where we are less competitive and where we have to strengthen our competitiveness in order to balance the level of employment. Because if you ramp on down and you ramp the others up, you want to keep a certain level of employment. That is the reality next. So you say, okay, what are the competencies we need? What is the reskilling effort? And what does this mean for the overall employment? And last but not least, there is the next question, which is more, I would say, a political question. So you find out that in certain regions of Germany, I would say the old industrial value chains are in a kind of a cluster. So there is a big risk there, because if you ramp it down, in some there is only, let's say, 5% of the employment, but in some could be 50%. And therefore it could be that certain geographical regions have a lot of issues, and therefore government has to identify, let's say, what incentives or what benefits they give, or what new industries they want to relocate there, for example, hydrogen or whatever it is there. So that's an approach we have taken. I think it's a good one. It requires a national competence monitoring. I'm a little bit frustrated because we offered to our government such a concept 6 or 7 years ago. At that time, it was not appreciated. Now we see we need it because it's not only looking, let's say, to this industry, it also is extended to the education system, as Mark said, because the question is, okay, what kind of education do we need in the universities? We need tons of software developers. We don't have enough, thousands of them. Some people still believe you can retrain people. Yes, so some lady told me, okay, you can easily retrain an accountant to be a software engineer. It's ridiculous, sorry to say this. So therefore, I think many of them have to come from universities, and it will not be easy to retrain that many. And the other point is the culture. It was mentioned, the change in the organization. I think I'm coming from a software industry, and it's a completely different culture, how you lead people, how agile people are. So if I try to convince the unions that we need more flexibility, more agility in the working style, most of them are coming from the hardware business, and I know you have to protect people because it's hard physical work. But software is something completely different, and you can work 60 hours, and you can work from wherever, from the North Pole, and you can start working at 11 o'clock and at night. So it's just up to you, and how it's important that you are creative. And bringing these worlds together is extremely difficult now to get people an understanding, because you need more software even in classical industries where hardware is dominating. But as I said, leadership style, etc., is different. So I will leave it with that. There are other points. Might be if we come to it, I would be interested to talk about the system approach. But okay, that's for now.
Excuse me, if I can make a follow-up to Henning's comment. I was speaking to one of my a freshman in my own university recently, and they were figuring their major, what they were going to do. And they said, well, why would I want to learn how to do computer programming? I'm not going to be a computer scientist. And I said, well, you're not going to major in literature. We still make sure you know how to read. So it's the same concept.
Thank you very much. So second topics, Dr. Irie, I'd like you to comment on that topic about the retraining, re-education. You touched upon what you do at Hitachi. There are something that you can do inside a company and something that you cannot do. So for example, that what you can do, what you expect from academia or what you expect from the government, if you have any comments on that point. Well, first of all, at the beginning, listening to the discussion, it's not just the personnel, but as a plant or organization, how can we improve the flexibility of it? I think that is very important to overcome these rapid changes. Dr. Kagermann commented on this. So for that, we need the people to support that flexible organization. But when you, for example, assembling the people, retraining, re-educating people who are working on the assembly, and to what extent can you provide and secure the flexibility, that I think is going to be a challenge in the future. But for us, in order for us to survive, to people to have multiple skills and also flexibility would be essential. And the educational system, we also have an internal educational system. Another thing is inside a company, we need to actually do this our own. For example, whether people can utilize the leading IT capability to promote the DX or digital transformation. And based on that, we can gain and brush up our skills. That's something that we can do internally. Also, government or community, when you consider those factors, in South Carolina, Dr. Johnson talked about for example, the best practices, for example, educational curriculum, and how can you utilize it for the reskilling. We want to be able to share that. So I think sharing is important. Or inside the plant, people give up when they cannot do anything. That tends to happen. So maybe if you can do it this way or that way, so changing the mindset of people, so they start to think that they can do it. So actual experiences or actual cases, to share them is difficult to do on our own. So as a community or a government or country level, if we can share that with other companies, I think it would be very helpful. That's my personal view. Thank you very much. Let's move on to the third point. How do you move on to resolving those challenges? Already, Dr. Kagermann made the final comment, that is the system approach. So for the resolution of those challenges, I think that's important. So Dr. Kagermann, could you talk about the system approach? Centering around the system approach, could you make some additional comments?
Yeah, I don't know if they are helpful. Look, I'm from education, a physicist, and what you are doing your entire life is reductionism. That is, you have a system and you put it into smaller and smaller pieces until the pieces are small enough that you can deal with them, and then you put them together. We know that in physics that has limitations. I don't want to go into this. But on a societal level, I have concerns that it has limitations as well. I give you an example. I come back to the transportation system. So we have split our CO2 reduction goals, I think might be the same as in the US, down to sectors, to the industry, to the housing, to the transportation, and to agriculture. So everybody has a kind of a budget, what he has to save. You could call it the systems approach. So we have these subsystems and everybody has goals. So now coming to the issues. The entire transportation sector in itself is extremely complex, I can tell you. So now, but you have a big system and you try to address it. We address it with 240 experts. So that tells you it's not easy. Now you come to the first question. We want to be open on technology. Yeah. No, there's battery electricity, there's hydrogen, there's others. Fine, we are open. So the first question of a government will be, can we afford two infrastructures? The smart infrastructure for battery electric, I think, is a double-digit billion investment, at least for Germany. Europe, much more. Hydrogen company, they are now concerned. Is this not? We know it's much cheaper. So first of all, you can now answer the question, okay, it's good in parallel to go for hydrogen, like Japan is doing it. Now we come to the point, oh, hydrogen, green hydrogen is a scarce resource. And where is this best to be used? Efficiency? It's not in transportation. It was mentioned in steel, it's in cement, it's in chemicals, much more. So out of a sudden, there is a shift in the political rules to say, no, you are not allowed to go so much for it in mobility. We need it in other sectors. You see my point? And that comes over time. And therefore, I think out of governance, out for political and other constraints, I think you find out that might be how you split your system into subsystems is not right. Might be we should have split it in electricity and hydrogen across all sectors. And that's a little bit my point. I don't know if that's something in Japan, but what you miss now is you need an organization which oversees everything and making the right bets, yeah? Otherwise, what's happening is, I think you have past dependencies. That means now we all go for battery electric and might be in 6 years we find out it's not the right thing to do, just for those things. And that's my concern. So is a system in itself, is it split the systems into subsystems over time the right ones, and who is the one who making, let's say, a new cut according to new, let's say, site conditions or decisions within society, whatever. Our government is not doing it so far. So we still have our budget per sector.
りがとうございます。
Thank you very much. So those were the kind of questions and examples of the Germany. Anything, Dr. Johnson, could you talk about the United States?
Yeah, I thank you. I think one of the challenges that Henning points to here is in a system, often how you align your accounting method suddenly becomes the direction at which you try and apply your solution. And you often have improvements that cut across these things. And it's hard to predict what the impact will be on the verticals as a result of that change. New components, whether that's a virtual component or a physical component, changes a system inherently, right? And so we need to be flexible and agile as societies to be able to respond to these things. We still have the same goal. I think Germany, Japan, the US at the top level, absolutely the same goal. But it's often hard to, the easiest way to count these things are by the firm or by the sector, or, the economists wind up looking at it that way. It's not necessarily the best way for a technologist. So for instance, you point out hydrogen. One big new initiative in the United States is something they are calling the Earth Shot. If you look 10 years ago, we began something called the Sunshot. And when I say we, I was one of about 10 people in the United States government at the time that put that together, which was saying, how do we rethink the technology development around solar energy to radically drive down the cost, and what new things needed to be invented, and then realign the US federal budget around those priorities. And so instead of just looking at, say, solar cell production, it suddenly became things like the power electronics costs or the installation costs and the balance of plant costs, and innovating in those areas. And you can see now the levelized cost of energy 10 years later for solar is less than almost any other energy source out there. So, that is usually the US approach to things, is saying, what's the right way to innovate? So we're trying the same approach with green hydrogen, or with hydrogen. If you look at hydrogen, how it's made right now, there is 10 million metric tons of hydrogen used in the US economy per year, of which 70% is used in petroleum refining for removing sulfur from gasoline. All of that hydrogen is made by something called steam methane reforming of fossil fuels. So, but that costs about $1,800 per ton, or $1.80 per kilogram. So if we can't get green hydrogen to less than $1.80 per kilogram, all the policies in the world are just reallocating resources, other than the underlying economic driver of saying, we need to get that to $1 per kilogram. And so I think the US government, our energy department, is certainly now has that as an official target, realigning all of its research goals around hydrogen for that. And the thinking being, we don't know where it will be used in society, but if it can get to that price point, there will be economic opportunity, there will be growth, and we'll still measure the system, but it will wind up driving forward in the information that way. I think taking it back to Industry 4.0 overall, we can have the same approach. If we can get the cost of sensors, if we can get the deployment costs, the non-recurring engineering costs of systems, we've already demonstrated that these things work, that we can improve efficiency, we can improve productivity. The challenge we have is, how do we make that scalable? How do we make it so everybody can wind up using it? So how can we work together on these issues? Because this is a shared issue for Japan, the US, and Germany on this. And it is those areas that we're working on. So one of the costs is, how do we make sure that everything isn't a unique solution? Well, that's the role of standards and communication platforms, and making sure we're working on those things, so that companies, we all have international supply chains in all of our companies. Our companies are across these borders and shipping across these borders. So they don't want to invent it differently in different locations. They want to use the same platform. So how do we work together on standards and communications is certainly a priority. The second issue then is, how do we make it so that the workers deploying it, every company doesn't have to start at ground zero of training their workers. So how do you learn from each other? And beyond that, the systems in Japan, the systems in Germany and the systems in the US are different from each other relative to how our education systems work, but we have the same goal. So can we wind up learning from each other? I've enjoyed, I will say, we're speaking with some German colleagues, appreciating the differences in different regions of Germany. And that's made it relative to the education system, let's say in the area up around Berlin versus down, in Rhine-Westphalia versus down in Bavaria. Very different approach, or not very different approach, but enough different that you can learn things. Same thing with South Carolina versus Detroit versus California versus Texas. So can we wind up learning from each other of our regional differences, that those small changes are perturbations in the system that we can say, here's how we can optimize our education and learning system overall. And then the third area is, again, getting these global commitments to having our overall society move towards a more sustainable future, and having things like the COP26 meeting coming up, and getting that top level commitment of our national leaders to achieving that, I think is a key to wind up working together. Thank you.
ありがとうございます。ちょっとお二人。
Thank you so much. So, in the comments of the two professors, and in addition to what Shirasaka-san said, whether that is hydrogen or digital, when you have new solutions, new technologies, we can achieve new objectives such as carbon neutrality or better resilience. How can we design this architecture in between? That's what Professor Shirasaka said. In Japan, we have the shortage of architects. We can design somewhere in between, and we don't know how to find those human resources. So in terms of architects, how do you educate them in the United States and Germany? How are they trying to connect the objectives and means? So I'd like to hear what the two countries are doing in this area. Now then, Professor Kagermann, would you like to start off?
Yeah, thank you. That's a good question. I think in SAP, I always ask myself, do we have enough good software architects? We have in Germany, I guess, a different approach because you know that the German society is more consensus driven. That means in Industry 4.0, in this mobility I mentioned, in artificial intelligence, what we are doing is we try to bring representatives of all societal groups together and discussing those things and trying to find solutions together. That is sometimes a time-consuming and frustrating endeavor, but as I have heard from our Chancellor, she felt this is helping the government at the end to come to faster decisions, because a big part of the societal debate is done outside of the political environment and not influenced by politicians too much. So as much as, let's say, societal groups come together, the better for the politicians. And in some cases, we cannot do it. So I was a little bit frustrated because the divide, the societal divide we have in particular, if it looks to mobility, is unbelievable. There's really a big divide in the society, goes across all these discussions. You cannot have a pure fact-based discussion any longer. Emotions come up, meanings about how we should live in the future, and people have different opinions about the picture of the future, how we want to live. But what you can do at the end, if you don't come to a compromise, 80% you can manage the compromise, is that you can, I think, lay down exactly the assumptions people have behind the conclusions. That is always in a political debate not done, because people start to be emotional or making a power struggle or whatever, but you can distill out what is the assumption. And I give you a very simple example. It's too simple, but it's surprising that it takes your time. A basic assumption in one party of our society on green energy is that green energy will be a scarce resource forever. Interesting. I don't believe so. Up from these base assumptions, it's obvious that they say efficiency first, and now you come to, let's say, bringing down hydrogen and other things, because as Mark said, the conversion into hydrogen takes efficiency out. There's a ratio in between. So they are completely against it. And you say, why? It's stupid, yeah? But once you would accept the base assumption, you must follow them logically, yeah? Because then there is some logic behind. And we try, it's as simple as it is, to get these base assumptions out so that politicians can then say, okay, I'm as a politician on beliefs A or on beliefs B. I cannot prove it, but that's my core belief, and that's a decision that I have to do. So that's a little bit the way how we are working, yeah? Okay, so not an architect, but in a social debate, finding out compromises or, let's say, the base beliefs which are different in the society. Thank you. Yeah.
Yeah. I think in the United States, one thing that we are, a strength where we're able to do this is actually merging in our education system between higher education, 4-year and PhD, and 2-year. Not as much, I mean, yes, for the individuals that are going through training, but also for the faculty members. So we have a number of, for instance, at my university, we have an automotive engineering program where we have everyone from PhD programs, but literally the research labs are in the building where 2-year training is going on. So this reflects what people will have in their professional career. Often you don't see that in academics. It seems to be, ivory towers and separated from, MIT doesn't have a community college or 2-year people. It's MIT or Stanford, right? Where I think in a lot of the engineering schools across the US, we have the flexibility to be able to actually experiment that way. And it works very, very well, because what that enables is it communicates quickly from what's new being invented. And as we go through this exponential growth, it's going to only get faster, to what needs to be trained. And so then we wind up translating that information very, very quickly. Now that's the strength of a US system. I would say one of the weaknesses, or one of the underlying hypotheses, as Henning would say here in the framework, is that we are a capitalist society. Our students pay for their own education for the most part. There is a huge issue in the United States of our students going into debt in exchange to be able to go to higher education, to go to 2-year colleges. So in some extent, not having a workforce is a market signal being sent to the private sector about what they're getting. If they are not getting the workers they want, they need to pay for them. It's that simple. At the higher levels, that happens. Computer scientists, they are like professional athletes. They are constantly on the market and constantly able to wind up getting jobs. That's not a problem. As you move down into just that's PhD level and master's level computer scientists and industrial engineers and materials engineers. As you move into the 4-year, that's the need for continually refresh of your knowledge base. And so there they wind up having less flexibility. However, if you wind up reinvesting in yourself, you are continually able to wind up having a good career and having impact and all that sort of stuff. Then at the 2-year level, that's the majority of the workforce that's in there in manufacturing. And as long as we're actually asking people to pay, have them pay to get the knowledge that's needed by the private sector, we have a gap there. And so I think that's one of the priorities that's happening right now. Again, as I said, this whole new industrial commons is how do we build systems where people that normally would not be in a position to get that 2-year training, to be able to get that 2-year training. And in particularly in those areas around Industry 4.0 and information technology and manufacturing, because this is so important. I think there's an increased realization of that in the United States, particularly on some of the infrastructure news that's in the United States right now, that we need to wind up making that reinvestment in our own people.
Thank you very much. We passed 9 p.m., but I'd like to spend 10 more minutes, if I may. I'd like to take some questions from the audience. Just one question I'd like to pick up. Dr. Irie already mentioned this, but I'd like to ask this to Dr. Johnson and Dr. Kagermann. It's a kind of a big question about the ecosystem. How would it change in the major way with digital technologies? How will the ecosystem change with the digital technology? So could you respond, Dr. Kagermann, please?
Yeah, I believe, first of all, that a really dynamic or adaptive ecosystem can only be built with a lot of digital capabilities behind. That's the benefit that was talked about: transparency, sharing data, connectivity, real-time, silent commerce, all of things what's said. So it's not only that people are more or less putting data into computer and something comes up. It's machines communicate with themselves. I normally distinguish between two kinds. I have mentioned networks, and might be I have confused some people, but I did it in a way because I believe a network is not an ecosystem. Already, it's the first step. Might be it's let's say you as a robot producer might need complementary hardware and software, grippers and other stuff, and you build, I would say, a business network of complementary partners, business partners, providers. You manage that. It looks to the outside might be a little bit like an ecosystem, but for me it's not so much. There's one company that is driving this, that is networking, etc., and that need digital capabilities to do this. I believe in ecosystem, and therefore I think government has to be involved, is what Mark said. There it's also about governance. It's about a certain goal. It's taking the SMEs with us, not only the big guys who can afford it. So it's more a societal thing. Then it's like in nature. It's a vibrating ecosystem. And from that point of view, I mentioned that is beyond technical capabilities. It's about this business understanding and, more important, a joint governance or joint governance rules, which I have to say, to be short, is a big issue, because even in Europe, I think everybody who follows the discussion knows that not all of our member states are following certain rules, even not those we believe are democratic ones. But you can imagine how difficult it will be if we come to global ecosystems, what we want to have. Then it means that most societies have to give in, or at least to find a level of certain rules they can base governance on. And that is a challenge for the future, I believe.
Henning, I agree with you completely that the starting point is making sure we've got good governance, not just also for the rules and regulations, but again, this idea of norms, which are much faster moving issues. We will slower, the technology is moving faster than we can make decisions about sort of legislative questions, as opposed to practical questions of what should be done and what we as a shared society and a shared supply chain, for lack of a better term, are working around these things in the ecosystem overall. The other part that I think will get integrated into and is part of Industry 4.0, but I think is going to be a higher and higher priority as we have effective translation of new technologies into people that can wind up accomplishing goals in different places. There'll be competitiveness between different regions of the world that can do that the most effectively, that will advantage. They'll be able to do it most effectively in different specialization, which will mean that there will still be continued exchange and trade, particularly between similar countries. I would expect the trade to only grow between Japan, Germany, and the United States, and economic benefit for all of us. But this also brings in the importance of logistics. And logistics on this isn't just optimizing your travel route. It is now, how do we wind up having the infrastructure so that a transmission made in Nuremberg can wind up getting onto a most efficiently into a assembly line in Spartanburg, South Carolina, and then have the car delivered to Japan, or however possible, all as efficiently as possible, where you've got maximum flexibility. As the products get more complex, they are more global, and logistics suddenly becomes the key element to keeping these ecosystems working together efficiently.
Thank you very much. Now, time is almost up, but last topics. Dr. Kagermann, Dr. Johnson, any expectations that you have from Japan and RRI? And maybe I can have a last word from Dr. Ide as well. Dr. Kagermann, any message?
Yeah, make it short. I have two things. One is Japan should continue to work globally, let's say, on standards and norms, like Mark said, on all three areas. I would say we call it ESG in addition to the technical things. E is environment. We still have no global accepted standard and norms how to measure environmental progress. Interesting. The second is social. I think financial investors look for social, but we have no accepted norms. What is good, let's say, in the social environment? We'll not dig into it. And the third one is governance. We spoke a lot about. But if you combine those things, and more people are combining it, I think we have to work hard to come to some ground we have together. The second point is, I think Japan has very good ideas in human-machine collaboration. We worked with Japanese colleagues, and I appreciated that, because Japan is, let's say, the first country with an aging population to solve that, and we can all learn from Japan. And on the other side, I think the ideas in Japan to solve this are more advanced, I would say, than in our society. So if Japan would, let's say, make even more progress and share this with other countries who come later, not US as a young society, but with Germany and might be China later, which are aging societies, I think that would be helpful as well. Yeah.
Thank you. The US is aging too, but we all are. But yes, I think over the next year in particular, what I hope we wind up doing, particularly between Robot Revolution Initiative and the United States on organizations like the Clean Energy Smart Manufacturing Innovation Institute, is we're able to build a bit more formal processes as we're coming out of COVID. How do we wind up working together? I think that there are partnerships between Japan and, for instance, Plattform Industrie 4.0 in Germany that have been a great benefit for both of them. I would hope that we can wind up having more formalized relationships between those institutes. These are all in the US what are referred to as public-private partnerships. But I think in this case, the private sector is pushing our public sector to work together. Which is a good thing. So I think, and the public sector certainly is responding on these things relative to, especially ESG issues that Henning points to. So I'm looking forward to a positive year and getting back together next year on these issues.
Thank you. For representing Japan, Irie-san, would you like to say something at the end? Not representing Japan, just representing a company, someone who is involved with the management of a company. We are asked to reduce carbon emission, decarbonize. We are asked to control the COVID infection. But all of these issues need global cooperation. So as has been said, we need to make rules. ESG is a good word, as Professor Kagermann mentioned. From that point of view, we, Hitachi, want to contribute to society positively, especially in Omika plants. we want to be taking actions. This is a great opportunity today where we can share what we are doing broadly. Hopefully, the whole society will be able to share this value that we believe in. And it's, however, very difficult for one single company to lead this major movement. Today, the symposium is organized by METI. On a national level, rules must be written, and companies can set up KPIs, not just profit-making KPIs. We need non-financial KPIs set, and I think we need to have global discussion on some of these non-financial KPIs. Thank you very much. We could continue on and on in this panel discussion, but time is up. So we want to close this panel discussion. We asked you first about the past 1 year. We talked about human education, re-education systems approach. And lastly, we received messages of what you expect of Japan and RRI. We want to respond to your suggestions. We will continue on. We still have some more days for this international symposium. So, the next session, day 2, will be on October 13th. After several days, on Wednesday, at the same time, we will start at 7 p.m. up to 9 p.m. Japan time. I'd like to invite you back to day 2 event. We will be looking at manufacturing innovation practices and workforce development in the United States. With that, we would like to conclude day 1 symposium. Thank you for participating.